Hello, my name is Sean, and in this tutorial, we shall move on to the Process Manager and look at how the processor and its manager work to process the jobs being passed through to memory. It is important to understand that processors vary in performance, speed, and bandwidth, so results vary from machine to machine. But there are some factors to appreciate. The clock speed refers to the speed at which the processor can execute instructions. So, the quicker the clock speed, the more cycles are run, and essentially, the more instructions are carried out. Do not always be fooled, though. The efficiency of the processor's architecture determines how much work the processor actually does. The bandwidth determines how much information can be processed in one instruction. The wider the bandwidth, the more that can be fitted on and sent. Think of it as a motorway. The wider the road, the more cars, or in this case, instructions, can be run at the same time. The processor has its own version of memory, also known as cache, that exists on the die of a processor. Because it has less time to travel, it is usually checked first before calling in a page from the RAM. Cache can be accessed between 5 to 10 times faster than accessing the RAM. A process scheduler is in charge of making efficient use of the physical processor. There are two parts to this. One is the job scheduler, and the other is the process scheduler, taking note that a job can consist of many processes. It can juggle many jobs. A process can be in 5 different states: hold, ready, run, wait, and finish. Hold is controlled by the job scheduler, and as the name suggests, it is holding the job until it has permission to run. Think of a car race. You cannot start the engine until the starting signal has been called. Now, when your engine is on, you are in a ready state. The ready state is a signal to continue with the process. When the car is ready to proceed, it is in a running state. In our case, it is currently processing the job. Throughout this time of running, there may be a concern of performance, so a check with the team is made to ensure it is okay to start running again, returning to a ready state. If it is okay to run again, it goes back into a running state. But what if there is an engine failure? In that case, an I/O request page fault is presented, and the car is put in a waiting state until it has found the correct resource or part so that it can continue to run. This will loop constantly until the process has either completed or failed, where it is then put into a finishing state. Each process has a life cycle. The process control block is used as an identifier and contains basic information about the job. What is it doing? Where is it going? How much processing has it currently done? And most importantly, how much it has spent in using resources. With the use of a process control block, we can place those in the correct queues. Think of the queue as a linked list of PCBs. This has been Sean. Please do not forget to subscribe to the SMKS channel.